back. Okay, I fixed it. P1 now stays on this vertical line, which goes through the vertex of the parabola, which goes through P0, and in this direction from P0. And C is the second derivative, which is the same everywhere, also in P0 anywhere. So if I make C 0, then it is almost a straight line like this. I mean, then it is a straight line, but I can make it not 0, but only 0.01, so then it is almost a straight line. Now the idea is as follows. You assume that I want a somewhat larger value, I think. So the idea is that we have a curve, don't know what it is, but it looks like this parabola. At the moment we are in P0. And then I do a measurement in the vertex. So we jump to the vertex in terms of x. And you expect to measure this, of course. In which case it is, I mean, if the derivative is 0 and the height is what we expected, then the best fit is still the parabola. But if it deviates from that, then it's not possible to fit a parabola that looks like a parabola here and then still goes through that point. So the best fit is then a cubic. And I'm going to determine the cubic and draw it. I guess I can make use of a polynomial. Which I have one in tests itself. It must be constructed with the number of coefficient. And then the coefficients can be assigned to the reference that is returned by this operator. Where 0 is the constant factor. Yeah, and so on. I already did the math, fortunately for you. The quadratic, or the cubic is defined like this here. And the first one that we can calculate is g, which is the 0, 1, 2, 3rd coefficient. And it is defined like that. I guess in order to draw the cubic, I also have to calculate d. But let's start with these. Yeah, to calculate d, I suppose any either of the 2 points will do. Let's use let's use W0 as well. To d is then yeah, normally I do that like this, which is easier. See, this polynomial is created with 0 coefficients. Yep. So the d is currently 0. We can just assign these. That is so this should be 0 if it is already correct, and it should be larger than 0 if the resulting evaluation is not enough. So I must start with this value and then subtract the cubic at W0 from that. Right, then we have to draw this thing. It's probably again a Bézier fitter. Excusez-moi. Right, in debug mode, I have to pass a symbol name. Well, no. I think this vertical line here is my cubic, and it's definitely not going through P1. Nor does it look like this parabola in the neighborhood of P0. Something is very wrong. Okay, now I have something. Yeah. I think the formulas are wrong, not a little bit. You can see here that it is a cubic, but that's about it. That's a boomer. If this math is wrong, then I have to spend time on that. First of all, actually, there is some positive side to it. It does go through P0. Ta-da! Totally goes through P0, which means that this last line is correct. That line. But yeah, what about the rest? Now, if this matches, as far as I can see, these formulas. So yeah, the formulas are not correct. Let's go over it. So I wrote this today. For the backtracking, I would like an estimate on whether or not it is likely that the function L of W has a minimum between W0 and W1. The following values are known: the value at W0 and its derivative, and the value at W1 and its derivative. Now we also know the second derivative at W0. Namely, we have the parabola P of W, which we can write down as coefficients A, B, and C, which therefore means that if you fill in W0, then it must equal L of W0, which was known. Or just W here is replaced with W0. And if you fill in W0 in the derivative, which is B plus CW, sorry, B plus 2CW, that must equal the first derivative at W0. And the second derivative is then just 2C. This must be equal to whatever that is, second derivative. But since we have the parabola, we have A, B, and C. And yeah, I'm already drawing the parabola. It looks perfectly fine. So I definitely have A, B, and C here. Also have the vertex. So the W1 value. And let's stop there and see if we predicted what we did so far with that in the code. Okay, so we have a double zero value, x value of point P0. And L at W is then the y value of that point. And the derivative is then hopefully this, right? Hello, Tyrant Atlas. Maybe we can start with... No, that must be correct because I use it to calculate the parabola. And that works. And this is by definition just the value of C. So this is my parabola. And then we get that A and B can be calculated from that. And then I create my parabola, which again has A, B, C as coefficients when constructing it, where C is the one that's the coefficient of the W squared. Can check that here, and at least if the comment is correct, then that's how it works. And the parabola is being drawn, and that looks good. So yeah, I'm totally convinced that we have done everything correct up till now, otherwise it probably would never look good. Now the point 1 is being drawn as well, P1, so x coordinate must be W1, and then the L of W1 must be the y coordinate of that. Completely similar to this part here. So now we have those values as well. And they are printed. Yeah, well, I think they looked good. And then we get to the cubic stuff. So it really must, this must be what is wrong. Let's continue then. So I'm going to fit a cubic Q of W to define as D plus E times W plus F times W squared plus G times W cubed, such that Q at W0 equals L at W0, and the Q at W1 equals the L at W1. So again, we fill everything just in, W here replaced with the W01. That must be equal, and then we can subtract that, and then we get this minus that on this side, and on the other side we get W0 minus W1 times E. The D is just d minus d, so you won't see that anymore here. W0 squared minus W1 squared times f plus W0 to the power 3 minus W1 to the power 3 times g is L of W0 minus the L of W1. I mean, that really looks correct to me. Furthermore, we have that the first derivative of q, which is e times 2f w plus 3gw squared, and then filling in w0 for that, so you get e plus 2fw0 plus 3gw0 squared must be equal to the derivative in that point. Same for w1. These two formulas are correct. Finally, we have that the second derivative in w0. Nah, I'll have to do that from my head, or I can just look at this, which was the first derivative. So then the constant is away, and we are left with 2f here. And this 2 comes there, or this 6g, and then that becomes a 1. W, and then we fill in w0 for w, so then you get this formula, and that must be equal to 2c, which was that value. I don't see any error there either. Nevertheless, I'm going to ignore 3. Which means that the derivative could be anything in W1, but doesn't even go through that point yet, so not related. Multiply equation 2 with W0 minus W1 to get W0 minus W1 times e. That's this term. Plus 2 times f times W0. And also times that. So yes. Plus 3 times g times w squared times that factor. Oh, it'd be that one. Equals W0 minus W1 times that one. And then we subtract that from 1. So then we get this minus that. That's 0. And then this minus that. So in other words, W0 squared minus W1 squared times f, but minus 2 times W minus W1 times W0. That is times f, and you have to subtract that from this thing. So yeah, totally correct. Plus, and then we get this, that's here, minus this. Yep, all times g. I don't see a problem there. And then we get this, which is this part, minus this. Looks okay to me. Now note that this can be written as minus W0 minus W1 all squared. Okay, I have to work that out. This is minus 2 times W0 times W0. That is minus 2 W0 squared. Subtracted from this plus 1 W0 squared leaves a minus W0 squared. And then the minus W1 squared. And then this minus and that minus becomes a plus, so we still have left 2 times W1 times W0, or 2 times W0 times W1. That looks correct. Equals minus W0 plus, we need a minus now outside the brackets. So we get plus W1 squared minus 2 times W0 W1. And this is, of course, W0 minus W1 all squared. So this seems correct as well. Furthermore, W0 to the power 3 minus W1 to the power 3 minus 3 times W0 minus blah 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 blah. It would be this. I think I skipped a lot of intermediate steps here. Okay, let's just work it out. That is W0 squared minus 2 W0 W1 plus W1 squared. And then all of that must be multiplied with minus 2 W0 and then minus W1 times the same thing. Yeah. Right, so this times W1, I don't like the minus there, so let's distribute the minus. Now let's first put the W1 in. W1 times that, and then W1 times this. And this times W1. That's the W1. And then the minus means that this becomes a minus, and this becomes a plus, and this becomes a minus. And here we have the W0, so this becomes to the power 3, this becomes to the power 2, and this becomes W0 times that. Then the W0 has been put in there. And then let's multiply everything with minus 2. Minus 2, minus 2, minus 2. So this is minus 2 times that. Plus 4 times that. Minus 2 times that. Well, this is no longer correct, of course. This is just this expression. That does not look correct. No way in hell I'm getting a W0 to the power 3, right? Oh, there's a power 3 here as well. Never mind. Never mind. Let's combine a few things though. This is W0 squared times W1, and I have that here as well. So we can subtract that, and then we get a 3 here. And this one goes away. And this is W0 times W1 squared, which is minus 2 and then plus 2. So that drops out. So we can write this as that. But then I have to subtract 3 times W to the power 3. Yeah. That one is here. And then still this factor term. And then we can get out a minus 3 and a W0 squared. To removing the minus 3 means that this becomes a minus. Removing the W0 squared means you get that. And now we have exactly the same as this. Yeah. Therefore, that was correct. This is correct. And then what the hell happens? Oh yeah, fill that in. So this is not highlighted. This would be this W0 squared minus W1 squared minus 2 times W0 minus W1 times W. So that part, what is multiplied with F, can be replaced with this. So we get minus W0 minus W1 squared times F. Yep. And then we get plus, and then all of this is equal to this. Yes. So then I can replace that with this. W0 minus W1 squared times minus 2 times W0 minus W1. All times G. That G. Equals, and then just what is written there still. So 5 seems correct as well. However, I did rewrite that as this this whole part. Well, we have the W0 minus W1 squared times minus F. And then we have also a G with that factor. But then we have to multiply it with this. So this part is that part. That looks correct. From 4 follows that F is 2C minus 6GW divided by 2. In other words, just C minus 3GW0. Yeah. Fill this into 5 to get, so now we fill in this F here. So we get W minus W1 squared times minus 2W minus W2 minus and then F, where that is that. Yeah. Hello, Dave. There's an error in it. I have to check it. But I still didn't find the error. That is sad. Well, that is annoying. Let's put it that way. Okay, so we're filling it into 5. So in the end we get equals that. L dot minus times that's the same thing, and this is then rewritten as that, I suppose. Yeah, we have this times minus C. And then we have here that times G plus 3W0. Sorry, 3W0 times G. So plus, so we have this plus 3W0. That becomes W0 minus W1 times G. Looks also correct. Now, then we can solve G from that. G is then this minus that. There's definitely something fishy here. Finally, I think I found the error. We want this whole thing divided by that squared. From the looks of it, I just divided it by, not by squared, but just by the unsquared value. No, confusing. Let me just redo it. So we have this. And then I want to get G. So I'm going to divide by that. we get this divided by that, and then this divided by that, and then we have this. So now we have to add C, and then divide by this again. My God, doesn't even look remotely the same as what I have here. Seems to be the factor of W0 the missing. Maybe I should have put that in front of it though. Let's continue. So this was it, and then divided by that. No, by once, yeah. So this becomes a 3. And this becomes a 2. And this is divided by that. Yeah, this is just a factor of thingy missing. Let's write this as just dividing by the power of 3. And then maybe put the rest also on top. So I only have to divide once, haha. Well, like that. No, the rest might be correct. So from 2 follows the thing. So E is that minus 2FW. No, that should be a minus. Didn't code this yet, but okay, this is the derivative, yeah? The d drops out, you get a 2 in front of it, and here 3, and that's the derivative, yep. And then we get w is minus 2f plus or minus the square root of 2f squared minus 4 times 3ge divided by 2 times 3g. So the 2 here drops away against that 2, and we get rid of the 4 here. That's also correct. So that must be a minus sign, and g is completely wrong. I don't think so. I was going to use this. Sorry. Okay, now let's hope that this works. Yes, it works. That is, yeah, it just works. So now the derivative, this is the third degree polynomial, and the derivative, it goes through p0, it goes through p1, and the derivative is also the same here. Not just the derivative is the same, but also the second derivative should be the same. But I'll believe that. Now there's totally no minimum, as you can see. It just goes, very quickly downwards. So it was going a little bit flatter here, so we got mistaken, thinking that it would flatten out completely here and then go up again, but no, it just went down, 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 down. No problem there. Now, let's see. So even in this case, there is a minimum here now, but there's no minimum between P0 and P1. It just goes down. It's very much like this parabola at the moment. Very much. And then then it deviates more and more from the parabola, but okay, still no problem though. In this case it's equal to the parabola. And now it gets to the other side of the parabola, but there's still not really minimum, but actually there is. The minimum here is, there is now a minimum here, which is between P0 and P1. So we do have an overshoot at this point. And it sort of, it does depend on C. See? So I mean, all these values for C, it's even very clear here that the minimum is now between these two. But if I increase C, then at some point the minimum is in P1 itself, but that happens at the moment that it is in the exact parabola. And then if you go higher, then the minimum is, as long as there is a minimum, it's beyond P1. It seems to me that exactly at the moment that this point goes above or below the vertex Y is where the minimum is going from the left to the right. It's kind of obvious actually, because at the moment that you put them at the same height, the minimum is exactly at the same point. Same height means clearly that it is a parabola. The third degree polynomial is just a parabola, which means that the minimum is exactly in P1. And then if you put P1 above the parabola, then that means that, yeah, the minimum is here. It's between. And if it is below it, it's on the left or doesn't even exist. What about an extreme version of, no, okay, I can't see that anymore. Suppose everything scales as well, so why would it be different? It's still the same. Definitely, totally the same. So the math was difficult, but the answer is extremely simple. Namely, is the result, is the vertex above or below P1? That's the only thing that we want to know. No calculations required at all. Yep. Yeah, well, you gotta wonder if you can't just prove that mathematically. So we don't have to wiggle these things. You just know for sure that it is always the case. Yeah, it's also if I put it on this side. No, there's no minimum at all. Why is P1 so low? Why does P1 not change height at all? Oh, wait a minute. I can do this by like this. Idiot. Yep. Okay, so now to get something comparable to my test case, so we have a P1 here and a pretty steep slowdown, and then a parabola that look like this. Yeah, this is kind of the situation I had in my test, in the other test. It looks like this parabola. Sorry, it looks like this parabola. And but that oversteps the actual vertex with a factor of 2. Because the new P1 was actually higher than the P0 even, like this. And then I want to know, is there a minimum here? Well, clearly there's a minimum, and the reason is that P1 is above the Y value of the vertex. Okay, well, I'm going to use that as the check. The only thing, yeah, well, let's say at some point it's still okay-ish. Let's say if it is a little bit above it, but not too much, that's okay too. This is definitely okay, because now the minimum is on the other side, even before the minimum still, and we drop more than we anticipated. That would also be okay still. So at what point do you want to half the distance? I guess that maybe would be nice to know a formula for that. To the distance from here to there. think this is still reasonable. So when it is at 4/5, 80% of the total distance from P0 to here. Then we might as well use this point instead of, yeah, well, I guess it doesn't really matter. I think this would be faster. I don't know. I'll go on intuition and say 4/5. I'm sure there's some kind of mathematical justification for a certain value, but the only justification I can think of is the number of steps that you need to find the actual minimum with a certain accuracy. That would be quite involved to calculate. I could, however, continue on this and then simply make an approximation in P1. Let's draw a parabola in P1 with the derivative and everything that we have here. I don't have a second derivative though. I'm afraid it's going to use basically the same point then. But then ignore the second derivative here. Just make some kind of approximation that approximates both derivatives equally wrong. I mean, that's what my current code is doing. If I would draw that, then you would at least see what is the, say the parabola that would fit that, I think, would look a lot like this thing already. And therefore, you might as well use that point. But it would be interesting to see once it starts heavily deviating, if at all. If I put this at the height of P0 itself, yeah, I guess it would be kind of here or something. So probably would look like this. So it all doesn't really matter, actually. Okay. So this value is set, and then we get the actual value. And now I want to use set a boolean that says that we accept this point, or we want to halve the interval, that the step interval. Let's first just use the sign, because I'm not convinced that I get the sign always correctly. The thing worked for a minimum, but isn't this also used for other stuff like maximum? Do this the other way around. Okay, I press caps lock, I think. So in this case it's positive 2.8, and that is the distance from the bottom of the prediction here to the actual measuring point, which is huge. So this step should be rejected. It is considered to be too big. Now the diff is negative. Because the prediction was this one. And then the actual value that you measure is this one. Yeah. So because the negative, we say, well, we might as well go here, even though it's much lower. Because why not? And yeah, definitely a good decision, because it drops us almost exactly on the minimum that we were looking for. The stupid thing is, however, that after that it predicts this parabola. So while we are almost on top of the minimum, we completely step away from it again. This is clearly wrong. But the reason is that this parabola is going through 2 and 3, but you can't match both the derivative here and the derivative there. So I'm doing some kind of trick which completely fails, it's clear. I should have, well, a parabola that is this close to the vertex is more important. I mean, the derivative of it is more important than derivative far away. So I guess that simply because this derivative is so small compared to that one, I should weigh this derivative more heavily. And then I would get a better parabola. For example, if we would drop exactly in the minimum, then my next parabola should have its vertex exactly at that point. Yeah, hey, that's a good one. I'm going to weigh the derivative based on the derivative value itself. Nevertheless, after this it does now it's again way positive. Aha. The diff is positive. Which is the effect of the overshoot. So now we are not happy with going there. And then we're going to half that interval, and then I'm probably still not happy with it. What do I compare this with? That what? Yeah, this would be half and half and half and half until we're almost on top of this again. It's a very, very bad algorithm. Totally not working. The jump point is not bad, not really. It's more that the parabola approximation was so wrong. If we had a correct parabola, then it would be still a perfect fit on a parabola. is positive. Tiny little bit negative. But this is also a very important reason not to reject tiny values that are negative. It's not that important. There's no way I should halve the interval here. So here we have a case that we are looking for a maximum, and the diff is positive. Actually, I would say this is indeed, well, I don't care to go higher than I anticipated. Here the diff is negative. Okay, that's confusing. Thought positive meant that it was okay. Now it looks like the negative is okay. Yeah, this is extremely positive and extremely wrong. So I think that if you look for a minimum, then it should be a negative. And if you look for a maximum, then it should be... Oh, I'm looking at the wrong value. Fuck me. This one. It's still very large. Very large, yeah. So we're looking for a negative, then the positive value is wrong. And the other way around for a maximum, which actually makes sense. So just the y-axis is inverted. So. It's an union clause. Okay, so a positive diff now is okay, and a negative diff is not. But a little bit negative should be allowed, and it's still not clear to me how to compare that. For example, I thought that in the beginning we had this point here. This one, for example. It's pretty negative, but compared to what? I mean, that's a diff, it's 0.7, so on this scale it's just huge. Well, this arrow, yeah. Pcha. Question was though, what do I want to compare it with? What to do? Let me blow the whole window up, because it's a bit too small for my taste. Even though I need it while debugging or reading this. Right now, I'd like my window to be larger. Yeah. Okay, I'm going to bid. Or am I? I should go to bed. I'm going to do puzzle. White to move. Can threaten mate here. Rook there to defend does not help. Because check, rook in between mate. A rook there, however. So queen here then. Now rook there, same thing, dock mate. Rook there. This also stops the king move, by the way, but wouldn't matter. Still kiss mate. So queen here, rook there, and I have a check here, and yeah, the rook has to go back at mate. So that totally works. And then we have queen check. Well, I laugh and go up. No, I go up and then laugh, I think. But anyway, then the queen is here. Happy that it gave a check. Cannot defend this square. Cannot give check again without giving away the queen. This is the move. Oh, wait a minute. There's one more possibility. We are material down. Rook takes knight. It's probably still a move, but what else could I do? What else? What else can we do? Nothing. Just gonna do it. Oh my god. I'm so stumped about this. How can that not be the right move? Oh no. I guess it's king up or something then. I mean, don't tell me that the queen here is the best move. That's impossible. It is. I looked at that. But now what? It's not like you have anything now. Okay, can I take the rook? No. Be happy. Okay, I can take the pawn, and I threaten to go to the back rank, which wins the rook. And if the rook goes back, then we can do the mate threat from here. Here it is. Can't go back. Why is this wrong then? He takes, okay, and I was going there, and now, and then he takes my knight, yes. Then I take the rook, and then it's a draw. Okay, you kind of saw that. Kind of saw that, but I went for it anyway because I thought if we go here, then he just defends everything, and now I don't have anything. But I suppose we still have something, because if you take this pawn, you threaten to go there. The rook cannot go back. The rook cannot go here. The rook can do whatever it wants. It can still take my knight though. Let's start with a check. And then take the knight. And now it's made an 8. Yeah. How can I see that? How can I possibly see that? Okay, so pawn after rook takes knight, take with the pawn, and then we have a mate threat, unstoppable mate threat. Let's try this move out first. No, but the queen is so far away. It cannot participate at all. Just put it there. Bait in 3. Dum, ba-dum, 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 ba-dum. I definitely did not know that one. Queen and knight against rook and king. Exposed king. Right, and if I go there, and he takes here, and I take with a pawn, and I expect the same result. But oh no, the queen can come here, and now it defends. Oh, right, yeah. This is the problem. And if we go here to stop that. No, just go there. Now I have to give check all the time. Did that before as well. And black wins. Go did it again. Right. Definitely a thumbs down. I think this is not clear at all. It's not finished after the moves. Yup. Yeah, now first this one maybe. So not. Then I don't know. Sacrifice immediately. Jesus. So just, this is what I wanted to do, but not in that, now this is made. So, looks like a nice threat. But if you start with the queen sacrifice, then you, white can start giving check, and I don't know, you can put the rook there indeed. How it on earth is, I mean, I stopped thinking at this move because I thought, well, how are you gonna win that? And that's made in 9. How on earth would I have known that? Could I have known? Oh, the bishop. Yeah. Oh yeah. Yeah, no, of course. Ah, come on. This is ridiculous. This is ridiculous. So that's why it wins. Because after this pawn takes there, the bishop can cover the promotion square. Ah, come on. Absolutely ridiculous. So at this point you should see that, well, I can take knight, because if he takes back and I put my rook there, then I threaten mate with my knight, and he cannot defend that. Because the only way to defend it is with the rook here. But I play the knight anyway, and then if he takes it, I take with the pawn, and I'm a whole queen down. But that pawn is now going to promote there, because now the bishop, and then together with the rook, independent of all the checks that white can give, these pieces are all gone, so you can just give check and then come there, and then do that. No way. No. No way. So that is why I thought, if something like this is involved, I'm going to, you know, put my rook here first. Takes a bloody pawn immediately. Yeah. I looked at this move. Then I thought you can just move this. Maybe not even. King can still go away. Why is this the best now? You have to take here. Extremely unclear why black is better here. Extremely unclear. Why the hell is black better here? Tell me. All the pawns are gone. Spite checks. Another pawn bites dust. Really? Give that pawn away as well? Oppa, another pawn. Oh no, we can take here. Oh no, great. Take there. And then you have to see this move. Otherwise, it's also ridiculous. And another check. Yeah, definitely the best move there. And another check. Let's go for a draw. And exchange all pieces. And now we have three pawns up. And now I see that it is plus 6 because white is winning. I'm such an idiot. So black is not winning. Okay, that's what I wanted to see, and white is not winning. Okay, I'm sorry. White is better here, because you can just take that. Way too difficult. Way too difficult. Okay, I guess so. We have a free pawn on this side, so the king must move away, and then we can take that one, and it took cost 1, 2, 3, 4, 5, 6, 7, 8, 9 moves to promote. And white probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or something. I think you can just move here. And it's not a move. No, of course it's not a move. Of course it's not a move. Nothing is the move here, is it? What about this one? Also not. No idea then. No idea. Again. Maybe this one. No, thank God. This one. Yeah. Nobody knows why. I mean, why is that the best move? Now I can gobble up all the pawns. Okay, great. And now we're done. Oops, that's not the button you want. This button. Go back. That's the only winning move. Why not this move? I thought the king moves here, and yes, then we win. I was right. But no, if you do that, then he can do this move. And that's going towards promotion. I have to admit that. Yeah, that is true. Okay, so now we walk with that one. Now the king comes. And then we start to do that. And it couples up one, and I go there. It couples up another, and I couple up this one. No, yes, no. King goes there, apparently. We go here. No, I don't. I start walking. Oh, he's faster. He is faster. Queen. What an unfortunate decision of making. And so actually the king should have gone there. Promotes with check now, and then takes a pawn, and then gives something, does something, and then promotes to the second pawn. But if I take, it looks better. I even promote first now. But it's still a draw. Okay. We both promote. And now we are one step too slow because this pawn is coming from there instead of doing 2 steps or something. Still don't see it. No normal man can calculate that. Yeah.